Hey, what's going on everybody? So in today's video, I gotta explain closures in JavaScript. A closure is a function defined inside of another function. The inner function has access to the variables and scope of the outer function. By using closures, they allow for private variables and state maintenance. JS libraries and frameworks such as React, Vue, and Angular use closures all of the time. You'll see closures fairly often with function-based components. You have functions inside of other functions. Let me give you a very basic example. We'll have an outer function named outer. Within the outer function, we'll have a function named inner. The inner function has access to everything within the outer function, this scope. If I was to create a variable, let message equal the word hello, within my inner function, I can use this message variable. console.log my message. Now, if I invoke the outer function, nothing appears to happen. When we call the outer function, we're now within the scope. But then what? There's one of a few things we could do. If I would like to call the inner function from within the outer function, I would need to call it somewhere here. Let's call the inner function at the end. There we go. We have displayed the word hello. Everything within the outer function is part of a closure. We have a function defined inside of a function. This inner function has access to everything within that scope, including this message variable. One benefit of using closures is that any variables are considered private. Outside of the outer function, I will attempt to update our message. Message equals goodbye. Now, this doesn't work, as you can see. This message variable is in a different scope. It's kind of like it's in another dimension. What we've done here is we have created a different message variable in a different scope. Outside of the outer scope, I have no way of accessing the message variable. So that's one of the benefits of closures. You can encapsulate variables and make them private. Let me give you another example. A closure can maintain the state of a variable. We'll create a counter program. So I'm going to create a function to increment. Within the increment function, I will set a count variable equal to 0. I will increment our count by 1, then console.log. I'll use a template string. Count increased to, I'll add a placeholder. We'll display our count variable. Now, anytime I attempt to call the increment function, it'll increase our count by 1. But if I was to execute this function again, well, we're redeclaring this variable of count. We're resetting it every time we call this function. I can't get the count to go past 1, because we keep on resetting it. But by using a closure, we can have state maintenance. We can maintain the state of this variable, and remember where this variable was previously. I mean, I could take this variable and declare it outside of the function, but then we don't have any security for that variable. I will set the count equal to 1,000,000. We're maintaining the state of that variable, but it's not private. Anybody and anything can access and change that variable. A closure maintains the state of a variable and makes it private. What we'll do is enclose all of this code within another function. We'll create a function to create a counter. How do we access the scope within the createCounter function? Here's another possibility. We will return an object. We will need a set of curly braces. Our object will have a property of increment, and its associated value will be a reference to increment. There is a shorthand version of this. You can just use the function name as a property. We're returning an object with the method of increment. So now I'm going to create an object named counter. Counter equals invoke the createCounter function. This will return an object that has an increment method. So I'm going to take our counter object, use the increment method. Count increased to 1. Not only do we have an increment method, we have a count variable as well. You could say that what we've done with this outer function, it's very similar to creating a class. We can use classes to instantiate objects. In this case, we used a function to return an object. So if I was to take my counter and increment it again, our closure should maintain the state of that variable count. Count increased to 2. It's not resetting every time we call the method. Count increased to 3. Let's attempt to access our count variable. Counter.count equals 0. Then I will console.log our count. Reference error, count is not defined. Let's attempt to display our count variable. Console.log, take our counter object, access the count variable. It is undefined. We don't know what it is. It's hidden. Your closure can have more than one function. So what we'll do is create a getCount function. We'll use the getCount function to return our count if we need access to it. Function getCount. We will return our count variable. Within the return statement, we're returning an object. We will add another property of a reference to the getCount function. So now within our counter, we have a method to get the count variable. Let's console.log. I'll use a template string. The current count is, I'll add a placeholder, take our counter object, use the getCount method. The current count is 3. If I was to increment our counter again, well, that increased to 4. All right, last example. We're going to create a closure for a game where we keep track of points. We have a score. Let score equals 0. We'll define the functions. Function increase score. We'll have one parameter, points. In order to score some points, we have to pass in some points as an argument. Take our score plus equals our points. Then let's console.log. I'll use a template string plus add a placeholder, our points. Then I'll add PTS, meaning points. It's shortened. Let's create a function for decrease score. Change increase to decrease. Score minus equals points minus points. And then let's get our score. Function get score. Return the score. If I need to increase the score, I will invoke the increase score function. But I have to pass in points. We scored 5 points. Let's do this again. We scored 6 points. Let's decrease the score. I will subtract 3 points. Minus 3 points. Let's get the current score. Console.log. I'll use a template string. The final score is, add a placeholder, get score. The final score is 8. I'm going to add points after that. 8 points. All right. Problem with this is that we can take our score and set it to anything. You scored like a kajillion points. So for some security, let's enclose all of this code within a closure. I'll create an outer function. Function create game. This will return an object. Let's cut all of this code, paste it within the outer function of create game. And then, at the end, we will return an object that has references to these functions. Return an object. We need curly braces for that. A reference to increase score, decrease score, and get score. So now, I will use the createGame function to return an object. Const game. Game will be our object. We will invoke the createGame function and return an object. So now if I want to increase the score, decrease it, or get the score, I have to use the methods of this object. Game.increaseScore, game.decreaseScore, and game.getScore. We have 5 points, 6 points, minus 3 points, and then we have the final score of 8 points. Well, everybody, those are closures. Think of them as a function defined inside of another function. The inner function has access to the variables and scope of the outer function. These are used frequently with JS libraries and frameworks such as React, Vue, and Angular, especially when you work with function-based components. And well, everybody, those are closures in JavaScript.